Everyone, in the last few videos we're taking a look at examples with sequences. Today we're going to be looking at examples dealing with series. So here's the first example. Begin with the series, the sum from k equals 0 to infinity of 1 over k plus 1 times k plus 2. Does the series converge, and if so, to what? So as always, feel free to pause the video, work on your own solution, and then I'll reveal my own solution. So we're asked to determine whether the series converges. So we're going to examine partial sums. So some preliminary work we might want to do, we're going to take a look at what's inside this series. So can that simplify down anything? Which it can. We see 1 over k plus 1 times k plus 2 equals 1 over k plus 1 minus 1 over k plus 2. So we can see that when we write out the partial sum in the this form, the 1 over k plus 1 times k plus 2 form, like this, we have 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over n times n plus 1 plus 1 over n plus 1 times n plus 2. Because we showed that this form is equal to this form, we can transform the partial sum to be written in the form 1 over k plus 1 minus 1 over k plus 2. So we get 1 minus 1 half plus 1 half minus 1 third plus 1 over n minus 1 over n plus 1 plus 1 over n plus 1 minus 1 over n plus 2. So distributing these addition signs into the parentheses, we get 1 minus 1 half plus 1 half minus 1 third plus 1 over n minus 1 over n plus 1 plus 1 over n plus 1 minus 1 over n plus 2. So as you can see, since all but the first and last terms occur in pairs with opposite signs, the sum telescopes. So what this means is there's nothing really to cancel out this one, but we can see that we have negative 1 half plus 1 half, that's 0. Negative 1 third plus 1 third is in the ellipsis. And same with the minus 1 over n, it's also in the ellipsis. And then we also have minus 1 over n plus 1 plus 1 over n plus 1. So everything besides the 1 and minus 1 over n plus 2 is going to sum to 0. So that's why the partial sum equals 1 minus 1 over n plus 2. So finally, we can take the limit of the partial sum as n approaches infinity and find that the partial sum approaches 1, which indicates that the series converges to 1.